Hiya, Mr. True. Well, we just learned how to factor. Now let's use those skills to practice another skill that we all love so much, which is fractions. And these fractions you're not going to be able to just put into your calculator. No, these are going to be algebraic fractions. And over the next few videos, we're going to be doing these where we're just going to simplify them, then add and subtract them, and then multiply and divide them. Basically, this is just going to be a review and reminding you of how to deal with fractions and allowing you to have some extra practice on factoring. So, we have 3x squared plus 13x plus 4 over x squared plus 2x minus 8. This is written so that the numerator and denominator are factorable, and you're going to find those common factors, not terms, but factors, and cancel them out. Well, our top polynomial, our top quadratic trinomial, has a leading coefficient that's not equal to 1. That means it takes a little bit of extra work to factor. So what we're going to do is, I'm going to do some scratch work here off the side, and then, so I don't have too much of a mess as I work at my problem. And what that scratch work is take the leading coefficient and constant and multiply them together. So that's going to be 3 times 4 is equal to 12. And now we're going to be looking for factors of 12 that add up to the middle term. Well, we have 1 and 12, 2 and 6, and 3 and 4. We want to take those factors of 12, which are 1 times 12, which does equal 12, and when you add them, you get that middle term, or the value that equals the coefficient of our middle term. So we're going to then rewrite, I'm doing this again, I'll scratch work off to the side here. I'm going to take this and rewrite it so that the middle term has these two coefficients. So we have 3x squared plus x plus 12x. Now 1x plus 12x is equal to 13, right? So I'm just making this top, this numerator, the top polynomial, just look different, not change its value. Plus 4. Okay, so we're going to factor by completing the square. Now out of these first two terms, we have a common factor of x. So that's going to come out. Now we're doing that with division. 3x squared divided by x is 3x, and 1x divided by 1x is just 1. We want to take out a common, the greatest common factor out of the last two terms, and between 12 and 4, the biggest common factor, divisor, is 4. So we're going to take that 4 out, and 12x divided by 4 is 3x, and 4 divided by 4 is 1. So now, as we factor by grouping, what we're looking to make, if this trinomial is factorable, is that we have again the same factor, the same stuff inside these parentheses, and indeed we do. We have 3x plus 1 and 3x plus 1. So now we're going to factor that out. And again, now with the 1 plus sign here in these parentheses, we have one big term plus another big term, and those two terms have a common factor of 3x plus 1. Okay, so this is going to be our factored form of the numerator. We have 3x plus 1 and x plus 4. I'm not going to have to do any extra scratch work for the bottom quadratic degree of 2 trinomial because the leading coefficient is equal to 1. So that's going to be a lot more straightforward. We're just going to put the factors of the first term in the first two blanks, which has got a leading coefficient of 1. It's just going to be x and x. When our constant, when the last term is negative, then in our parentheses we need to have two different signs, 1 plus, 1 minus, so that when we take these and if we were to check our work and distribute these back together, we want our last value to be negative. That means we have to multiply two values with different signs. We're looking for factors of 8 that subtract. If this were plus, it'd be saying add. We're looking for factors of 8 that subtract to be 2. Well, we have 1 and 8, that subtracts to be 7. 2 and 4, which can either be negative 2 or positive 2, depending on how you do your subtraction. And we do want a middle coefficient of positive 2. So we want a positive 4 and a negative 2. And if you're not sure if that's right, distribute the denominator or numerator back together and make sure that it equals one of your original polynomials or both. Now, we have these common factors that will cancel out the x plus 4. And again, you can cancel out factors, not terms. This is one number being multiplied by another number. So these in the numerator are two factors, one of 3x plus 1 and one of x plus 4. And again, we have that same factor because it's being multiplied to something else in the denominator. Our final answer comes out to be 3x plus 1 over x minus 2. Couple of things here. Again, with the factor idea, if I have 3 times 2 over 2, well, this 2 is being multiplied by the 3 and we have a 2 in the denominator. They will cancel out, of course, and get an answer of 3. Now, if you wanted to do this in your head, 3 times 2 is 6, and 6 divided by 2 is equal to 3. However, if that were a plus sign, then this 2 would not be a factor, it would be a term. Addition, subtraction separates your terms. If this were a term, and I attempted to cancel that out, I would get, well, 2 divided by 2 is 1, so I'd have 3 plus 1 over 1, which is equal to 4. And last time I checked, 3 plus 2, which is equal to 5, 5 divided by 2 does not equal 4. So again, do not cancel terms. Okay, can you tell I get students doing that all the time? Secondly, let's talk a bit why you're doing this. What is this going to be used for later in algebra? Well, this factoring process, again, like I mentioned in other videos recently, is going to be used for solving equations. Factoring is one way to solve equations. Another thing is, if I were to set this equal to y, and say we're in at the end of an Algebra 2 class or in pre-calculus, we would be, graphing these rational functions. You might want to look that video up if you want to look ahead and see where all this stuff is going to be used for. And when you graph that rational function and you have this common factor that's cancelable, you cannot divide by 0, right? So this, after we factored here, and we can see that x plus 4 and x minus 2 are our two factors, well, the values, if I were to take these and set them equal to 0, I'm going to kind of jump ahead and get into solving by factoring here. If x plus 4 equals 0, and that means that x equals negative 4. If x minus 2 equals 0, then we have the solution of x equals 2. Well, these values, either one of these values will make this entire denominator equal to 0, and you cannot divide by 0. So graphing, if you were to try and graph this, probably beyond where you're at in math right now, then you would have something called a hole at the x value of negative 4, and you have a vertical asymptote at x equals 2. I don't want to go into teaching that, but this would have an application in graphing. Now, as far as just plain algebra is concerned, if that's what you're studying, then this is going to be the restrictions on our domain. So this original function here, this original expression, let me take the equal sign out of there, this original expression has a domain where x cannot be equal to the value of negative 4 and 2. So we have this a fractional or this rational algebraic expression. I've shown you how to factor and cancel, and I've also talked to you a little bit about domain. If these values of negative 4 and 2 are plugged in here, you're going to divide by 0, and that makes the fraction undefined. Next example, we have 12x cubed minus 14x plus 12x. Now the first thing in factoring, and we'll have the same issue with the bottom, well, it's not really an issue, but something you need to know how to do. Again, the first step of factoring is make sure that you find any greatest common factors that can be pulled out of all the terms. The first step, this is the first step of factoring. So 2, 14, and 12, these are all divisible by 2. All three of these terms have a value of x, or a factor of x. So we're going to factor out that x. And we're going to be able to take out the lowest exponent. And the lowest degree or exponent that we have in that numerator is 1. This can be about 3, 2, and then finally 1x. So 2x to the third power divided by 2x. 2 divided by 2 is 1. You have 3 x's and you're taking one of them out, so you have x squared. Negative 14x squared divided by 2. Now 14 divided by 2 is 7, negative 14. So negative 7. You have 2 x's, you're taking one of them out. And then 12 divided by 2 is equal to 6. All over. We have a common factor of 4, so we're going to take that out. Both of these terms have an x in them, so we can take one out, or we can take two of them out. Lowest power, lowest exponent. So 4x to the third divided by 4x squared, 4 divided by 4 is 1. You have 3 x's, you take two of them out, you're left with 1x. Again, 4 divided by 4 is 1, but it's negative, so negative 1. X squared divided by x squared is it's also equal to 1. So I factored the numerator and denominator, and some stuff is going to cancel here. Let's go ahead and do that. 2 divided by 2 is 1, and 4 divided by 2 is 2. And we have 1x here and 2x's down here, so one of these x's is going to cancel with one of these 2x's down here, so we're going to be left with 1x in the denominator. Now if I clean this up a little bit, I'm going to have x squared minus 7x plus 6 over x times x minus 1. Now you might think you're done, but there's not always just one step of factoring, and I'm not doing just super easy questions in this video. In case your book doesn't give you hard enough examples for you to get through your entire homework, I'm not just picking the easiest stuff here. So this numerator is factorable again. We have a leading coefficient of 1, and there are factors of 6 that add to the middle term of negative 7. If your constant is positive and your middle term is negative, then when you do your factoring, your two parentheses, your two binomials, are going to have minus signs in the middle of those. So we have x minus times x minus, that's x coming from the square root of x squared, and the factors of 1. What factors of 6 add to negative 7? Well, negative 1 times negative 6 is positive 6, and negative 1 and negative 6 add to be negative 7. Now we have another set of common factors that are going to cancel out. We have x minus 1, so then our final answer is x minus 6 over x. Do not be tempted to cancel these x's out. This x is being subtracted to the 6, which means that that is a term, not a factor. Now when I look up here, getting back to domain again, if this factor right there, which is just simply x squared, or x after it reduced, but the original x squared, if that term, or that factor, excuse me, equals 0, then the entire denominator is going to equal 0, and you can't divide by 0. So x cannot equal 0, and if you make a little tiny equation on the side, x minus 1 equals 0, and you solve that by adding 1 to both sides, you'll find out that x cannot, or also cannot equal 1 because you'll divide by 0 again. So your domain for the original problem is x cannot equal 0 and 1. Now please note, I am not looking at the finally reduced fraction to determine the domain of this expression. Or if I just again stick a equals with a y there, I'd be talking about the domain of the function. I'm not looking at the reduced form, I'm looking at the original problem to determine what can x not be equal to. I've got 6 examples for this video. I'm going to try and pick up the pace a little bit. I know I'm doing a lot of explaining and kind of going slow, and I don't want this to be a 35, 40-minute video. So let's whip through the next few examples, and hopefully not too fast though, so you still understand them. Okay, next 2 examples. We have x squared plus 3x minus 28. Factors of 28 that subtract to be 3 are going to be 4 and 7. So we have a negative, so we want different signs. So we have x plus 7 times x minus 4. And in the denominator we have 4 minus x. Now you might be very tempted to just cross these out, but please don't, because, well, what's 5 minus 2? 5 minus 2 is equal to 3. And if you turn that subtraction around, you get 2 minus 5. That's not equal to 3, it's equal to negative 3. Same answer, but the signs are different. So what you need to do is remember that, so that you can go, okay, well, no big deal. I need to reverse the order of the subtraction. These do not cancel out. So before you cancel these out, if you do it enough times in your homework, probably not. This is a little bit of an advanced thing here. You might just do this in your head, but to show all the work, we want to reverse the order of the subtraction, and we're going to do that by factoring out a negative 1. So we have x plus 7 times x minus 4, and we're going to take a negative 1 out of these two terms. They're not going to change the values, just the signs. So 4 divided by negative 1 is negative 4, and negative 1x divided by negative 1 is positive x. I mean, I guess you aren't changing the value, but you're going to reverse the order of that subtraction. And now the x minus 4's cancel out, and we end up with a final answer. I would be totally happy if my student left it like this, so we'll write it as, take this negative 1 and bring it up. Negative 1, or just negative, parentheses, x plus 7. Over here, we have a polynomial to the third degree. Now, trying to factor third degree polynomials can involve some pretty advanced algebra techniques, synthetic division and the rational zero theorem to run through all the possible zeros that you'll check with synthetic division. So if this doesn't factor by grouping, probably doesn't factor at all. At least not at this stage of your algebra class. So these first two terms both share an x. We're going to factor this by grouping. And we're going to be looking for a greatest common factor between the first two terms and the last two terms. And hopefully when we do that, it'll come out to be kind of nice. We have, again, in our first two terms, both of these have an x, and we can take out the lowest number, or the lowest exponent, which is x squared. So we have x squared, x cubed divided by x squared is x, minus, and then 2x squared divided by x squared is going to be 2. In the last two terms, we have a negative 2x and a positive 4. Now, we can divide a 2 out of each of these terms, but I want my x to be positive and my constant to be negative. So I'm not going to just take a 2 out, I'm going to take out a negative 2. So negative 2 divided by negative 2 is 1, x, and positive 4 divided by negative 2 is negative 2, over, well, now, we have here, if you've been watching my videos, I've done this as a example in past videos, so hopefully you know what's going on here. We have a power, a degree, which is even. And then we have a middle term whose degree is half of the original term. So we have a power of 4, and then it gets halved, that gets divided by 2 or halved, and we have a power of 2, and then it just sort of goes away, the power goes away. This will follow that same pattern that we've been doing for factoring quadratic trinomials. As long as your power gets decreased by half and then completely disappears in the last term, you're okay with that. We have a leading coefficient of 1, so the square root of x to the fourth is x squared. So we're going to have our two patterns here, and again, the square root of x to the fourth is x squared. We are looking for factors of 6 that subtract to the middle term of 1. Well, factors of 6 are 1 and 6 and 3 and 2, and the ones that subtract to be positive 1 are positive 3 and negative 2. Well, now what? Well, we're not done factoring the numerator yet. I just did the first step of factoring by grouping. Now within each group, we have a common factor of x minus 2, so I'm going to take the x minus 2 out of the top two terms and write x minus 2. That's this here. Now if I take x minus 2 out of the first term, I get x squared. And in the last term, I'm left with negative 2 over x squared plus 3 times x squared minus 2. And that common factor of x squared minus 2 cancels out. And here is our final answer. I've got 2 more examples for you. Bam! Last 2, like I said, here we go. We've got a difference of squares here. 16 is a perfect square, and this power is even. So we can divide that power by 2 through the square rooting process, and it'll come out to be a nice even number. We also have a negative exponent here. Let's get rid of that first. Anything to a negative power, if you want to write that exponent to be positive, you want to move its base to either the numerator of the fraction, denominator of the fraction, or the numerator. This is in the main line of the problem. It has a power which is negative, so we're going to move this into the denominator, or make a fraction and move it into the denominator, which is going to make that power of negative 1 positive. So this becomes, I'm just going to rewrite the problem here, x cubed plus 8. And it was to a power of 1, and that doesn't do anything anymore, just now that we've moved the base into the denominator, so I'm going to lose the parentheses. This is a difference of squares. So we're going to square root the first term, square root the last term. And that is going to create x squared plus 4 times x squared minus 4. The square root of x to the 4th is x squared. And the square root of 16 is 4. We just have one with a plus and one with minus. The denominator is a sum of perfect cubes. This has a power of 3, or any exponent that was divisible by 3, like x to the 6th, x to the 9th, x to the 12th. Those are all considered perfect cubes. And then, of course, the cube root of 8 is equal to 2. So this, remembering our pattern for the sum of cubes, is going to be equal to x plus 2, again, cube root, times x squared plus 2x, that's minus, plus 2 squared, which is going to be equal to 4. Now, I factored the numerator and denominator, and nothing cancels out. I mean, these problems are given to us in our textbook, to work. So, why is nothing canceling out? That's because the numerator still here has another step to do. This is a difference of squares. There is such a thing as a sum of squares, but there's not a pattern for doing the sum of, there's such a thing as sum of cubes and difference of cubes, but when you're talking about squares, there's only a difference of squares pattern. So this is going to factor again, and we get x squared plus 4 times x plus 2 times x minus 2. The square root of x squared is x, and the square root of 4 is equal to 2. I'll load that over. X plus 2 times x squared minus 2x plus 4. And now we have the x plus 2, those factors canceling out. And that is, I believe, yes, that is all that's going to cancel out. So we have x squared plus 4 times x minus 2 all over x squared minus 2x plus 4. And I don't really need these parentheses down here, but I'm sure your teacher's not going to make you distribute these binomials together. I will not be for my classes. Make sure that I have the correct answer here. Yes. Okay, moving on to my last one. This problem really looks a lot more complicated than it really is. It's following the same pattern I've done for all of these problems, except for I have a variable in my last term instead of just a constant. That's not really an issue because we have that variable showing up in the numerator, in the middle term. And remember that when you square root, because that's what you do with your variables when you factor them, when you square root this x to the 2n, like the square root of x squared is just x. The square rooting takes the power and divides it by 2. The square root of x to the 4th is going to be x squared, because x squared times x squared is x to the 4th. So the square root of x to the 2n is going to be equal to, well, what's 2n divided by 2? N. That's where these exponents come from in the middle term of this trinomial. So we're following the pattern that we need for being able to factor this just fine. We're going to have factors of our first term go in the first two blanks, and our leading coefficient is 1 at least, so that makes the problem a little bit easier. So the square root of x to the 2n power is x to the n power, and then x to the n power. We're looking now, because our leading coefficient is 1, we just have to look at the number itself. Factors of -4 that subtract to give you 3. Well, your factors of 4 are 1 and 4 and 2 and 2. Of course, that 2 and 2 subtract to be 0. So we want a positive 4 and a minus 1, because positive 4 times negative 1 is negative 4, and they also add up to be the middle term of 3. Now, I need to include that variable that's in the last term. So the square root of x, or y, to the 2n is yn times yn. Now, this is a bit of a complex problem, so if you wanted to make sure that it was right, x to the n times x to the n is x to the 2n, because when you multiply like bases, you add the exponents, minus 1 times negative 1 is negative 1, x to the n, y to the n. And then, so we just did this step here. And then positive 4y to the n times x to the n is positive 4y to the n x to the n. And then finally we'll have our minus 4y to the 2n. Well, this is adding up to our middle term of the positive 3xy to the n powers. So that does factor and it is correct. So a little bit quicker with the denominator here. This is going to be x to the n and x to the n. Factors of 8 that subtract to be 2 is they're positive 4y to the n and negative 2y to the n. What common factors do we have? It's the first two. And that is our final answer, and that is the end of my video. Go do your homework.